Download this code from codegive.com, link in the description below. OK, let's dive into the common pitfall of accidentally subscribing to signals in Angular templates, creating performance problems and unexpected behaviors. I'll provide a detailed explanation, examples, and best practices to ensure you're using signals effectively and avoid the don't subscribe in the template trap. The problem: subscribing to signals in templates. The seemingly simple act of directly accessing a signal's value in your Angular template using .value or can lead to significant performance issues if you're not careful. This is because every time Angular's change detection runs, which can happen frequently, think user input, timers, or external data changes, it will re-evaluate that signal in the template. In some cases, this can cause the signal's computation to run unnecessarily many times, bogging down your application. Why is this different from rxjs observables and the async pipe? You might be thinking, wait, I use observables in my templates all the time with the async pipe, and that's fine. That's absolutely true. The async pipe is designed to handle observables efficiently. Automatic subscription / unsubscription *, it subscribes to the observable only once and manages the subscription life cycle. When the component is destroyed, it automatically unsubscribes, preventing memory leaks. Change detection strategy awareness *, the async pipe integrates well with Angular's change detection. It only updates the view when the observable emits a new value. Signals, on the other hand, don't have this built-in mechanism for automatic lifecycle management and optimized change detection within templates. Directly accessing the signal's value forces Angular to re-evaluate it on every change detection cycle. Code example: the naive and bad approach. Let's say you have a signal that performs a somewhat expensive calculation. And here's what will happen when you type in the input field. 1. On input change updates input text. 2. This triggers a re-evaluation of the expensive value signal, because input text is a dependency. 3. Angular's change detection runs. 4. The expensive value in the template is re-evaluated on every change detection cycle, even if expensive value's underlying dependencies haven't actually changed again since the last calculation. You'll see calculating expensive value logged repeatedly in the console, even if the input text hasn't changed. This is wasteful. If the change detection runs for some other reason entirely, example a timer updates, another component changes, or a DOM event occurs, expensive value is still recalculated, even though it doesn't need to be. The core issue: unnecessary computation and change detection cycles. The problem isn't inherently with signals. The issue is that directly invoking a signal in a template triggers change detection for that specific part of the view on every change detection cycle, even if the signal's value hasn't changed. This leads to performance degradation if the signal involves expensive computations, example complex data transformations, network requests, these computations are performed more frequently than necessary. Unexpected side effects if the signal has side effects, which it shouldn't, but sometimes happens, those side effects can be triggered multiple times unnecessarily. Re-renders Angular will needlessly re-render that part of the DOM, causing layout thrashing and further performance problems. Solutions and best practices. Here are the recommended approaches to avoid this pitfall. 1. Use async pipe with an observable, when appropriate. If your signal's value is driven by an asynchronous source, example an HTTP request, a WebSocket connection, consider converting the signal to an observable using toObservable, and then using the async pipe in your template. This is often the best approach for asynchronous data streams. Key improvements. Asterisk to observable, this expensive value, asterisk converts the expensive value signal into an observable. This allows us to use the async pipe. Asterisk username $async in the template. Asterisk the async pipe handles subscription and unsubscription, preventing memory leaks and ensuring efficient change detection. Angular updates the view only when the observable emits a new value. Asterisk HTTP example. Asterisk it is highly recommended to use observables when dealing with HTTP requests. It is also a very good example of when the async pipe works extremely well. Asterisk take until destroyed. Asterisk a very common practice. It ensures that the user $observable will unsubscribe from it whenever the component gets destroyed. It protects from memory leaks. Asterisk inject. Asterisk Angular's inject function allows for dependency injection in class fields or functions, providing a cleaner and more flexible way to access dependencies compared to constructor injection in many scenarios. Asterisk.set. Asterisk signals values are set through the .set method, not directly. Asterisk cannot set computed signals. Asterisk you cannot directly set computed signals with this username.set. You would have to change the signal that triggers the computed signal. To use a read-only signal in the template, for simple values. If your signal holds a simple value, like a string, number, or boolean, and doesn't involve complex calculations, using it directly in the template might be acceptable, but proceed with caution. It's often better to err on the side of caution and use the async pipe or another optimization technique. In this case, the overhead of re-evaluating message on every change detection cycle is probably negligible, especially if the message signal rarely changes. Important consideration. Asterisk even for simple values, if the signal is frequently updated or if the component has many other change detection triggers, you might still want to consider using an observable with the async pipe to avoid unnecessary re-renders. 3. Minimize change detection frequency. Asterisk. Angular provides mechanisms to control change detection. Asterisk change detection strategy. On push. Asterisk this strategy tells Angular to only update the view when the component's input properties change or when an event originates from the component or one of its children. This can significantly reduce the number of change detection cycles. Asterisk mark for check. Asterisk if you're using on push, you can manually trigger change detection for a component using change detector ref. Mark for check. Here's an example of using on push. With on push, the component will only update if the value input property changes. 4. Use a pipe to memoize, cache, expensive computations, advanced. You can create a custom pipe that memoizes the result of an expensive computation. This means that the pipe will only recalculate the value if the input to the computation has changed. This is a more advanced technique and might be overkill for many situations, but it can be useful for very complex calculations. Then use it in your template and in your component. Important notes about memoize pipes. Asterisk. Asterisk pure, true. Asterisk this is crucial for the pipe to work correctly. Pure pipes only execute when the input value changes. Asterisk referential equality. Asterisk the pipe relies on referential equality, equals, to determine if the input has changed. This means that it works best with primitive types, strings, numbers, booleans, or immutable objects. Asterisk careful with objects/arrays. Asterisk if you pass mutable objects or arrays as input, the pipe might not detect changes correctly if the object's contents are modified without changing its reference. 5. Computed signals for derived values, often best. This is often the most appropriate solution for derived data. Instead of directly using the source signal in your template, create a computed signal that derives its value from the source signal. This ensures that the template only updates when the derived value actually changes. In this example, formatted message is a computed signal that depends on message. When message changes, formatted message is automatically re-evaluated. The template only accesses formatted message, so it only updates when the formatted message actually changes. 6. Untracked for rarely changing values asterisk. The untracked function from @Angular/core helps you access a signal's value without creating a dependency. This is useful when you need the value of a signal inside a computed signal, but you don't want changes to that signal to trigger a recomputation. This is a more niche use case. In this example, value is a computed signal. It uses untracked to access the current value of multiplier without creating a direct dependency. Therefore, when the multiplier changes, it will not automatically rerun the value computation. The value computation only reruns when base value changes. When to use untracked asterisk. Asterisk when you need the initial or current value of a signal within a computed signal, but you don't want changes to that signal to automatically trigger recomputation. Asterisk for configuration values or rarely changing dependencies that you only need to access once when the computed signal is initially created. Asterisk be careful when using untracked. It can make your code harder to understand if not used judiciously. Ensure that it aligns with the intended behavior of your signals. Summary table. Approach use case pros cons. Async pipe with observable asynchronous data streams, example HTTP, WebSockets, efficient subscription management, prevents memory leaks, integrates well with Angular's change detection, requires converting the signal to an observable, might not be suitable for purely synchronous computations. Direct signal access, carefully, simple values that rarely change, minimal performance impact. Simple, straightforward can lead to unnecessary re-renders and performance degradation if the signal changes frequently or involves expensive computations. Change detection strategy. On push components with minimal input properties or predictable change patterns reduces change detection frequency, improves performance, requires careful management of input properties and manual change detection triggering, if needed. Memoize pipe expensive computations that depend on specific inputs caches the result of the computation, avoiding recalculation if the inputs haven't changed. More complex to implement, relies on referential equality, might not work well with mutable objects. Computed signals derived data that depends on other signals ensures that the template only updates when the derived value changes, promotes data encapsulation and reusability, requires careful planning of signal dependencies, can become complex for very intricate data transformations. Untracked accessing a signal's value without creating a dependency prevents changes to the untracked signal from triggering recomputation, can make code harder to understand if misused, should be used only in specific cases where you don't want a dependency. Key takeaways. Be aware of the potential performance implications of directly accessing signals in templates using .value or prefer using async pipe with observables for asynchronous data streams and for cases where performance is critical. Use computed signals to derive values and ensure that templates only update when the derived values actually change. Consider change detection strategy. On push to reduce the overall change detection frequency. Test and profile your application to identify potential performance bottlenecks and optimize accordingly. Strive for clarity and maintainability in your code, even if it means adding a bit of extra complexity. A well-structured application is easier to optimize and debug in the long run. By following these guidelines, you can harness the power of Angular signals while avoiding the common pitfall of subscribing directly in templates and creating performance issues. Good luck.